The Chandrayaan-3 mission, launched by India on August 23, 2023, marked a historic achievement as it became the fourth nation to land on the Moon and the first to do so on the lunar South Pole. This mission, which included the Vikram lander and the Pragyan rover, made groundbreaking discoveries within a short period of just a couple of weeks. One of the most intriguing events recorded by the mission's Instrument for Lunar Seismic Activity, ILSA, was a potential moonquake, occurring 3 days after Chandrayaan-3 landed on the Moon. Moonquakes, seismic tremors that occur on the Moon, have been a subject of fascination for scientists and researchers for decades. The detection of these tremors is crucial for understanding the Moon's geology and internal structure. The Chandrayaan-3 mission also made significant discoveries on the south pole of the Moon, an area that had never been visited by any nation before. However, despite these achievements, there was one significant thing that Chandrayaan-3, like previous missions, failed to find on the lunar surface. Chandrayaan-3 landed near the south pole of the Moon, specifically at a point now called the Shiv Shakti Point, which lies about 600 kilometers away from the South Pole. This location posed several severe challenges to the mission, including rough terrain, perpetual darkness, and extremely low temperatures during the lunar night. Despite these challenges, Chandrayaan-3 was designed to last for 14 Earth days, or 1 lunar daylight period. During this time, it made significant discoveries, starting with observations of the lunar atmosphere. Despite being extremely thin, the exosphere of the Moon, which includes a secondary layer called the ionosphere, was examined by instruments on board the Vikram lander. The density and temperature measurements of this layer revealed that the plasma surrounding the lunar surface near its south pole is relatively sparse, with a density ranging between 5 million to 30 million electrons per cubic meter. This information is crucial for understanding radio communication, as higher electron density can affect the transmission of radio signals. However, the sparse plasma density suggests minimal potential delays for transmission and navigation systems if humans were to inhabit the Moon in the future. Additionally, the lander made an intriguing discovery just below the lunar surface. Temperature probes revealed significant temperature variations between the surface and deeper layers. While the surface temperature during the day reaches around 60 degrees Celsius, or 140 degrees Fahrenheit, it drops dramatically to about -10 degrees Celsius, or 14 degrees Fahrenheit, just 8 centimeters below the surface. This rapid temperature decrease indicates that the Moon's topsoil acts as a potent thermal insulator, which could be utilized in building future habitats for astronauts to shield them from extreme conditions and harmful radiation. On August 26th, 3 days after the historic landing, the Instrument for Lunar Seismic Activity detected a potential moonquake. Moonquakes can occur due to various reasons, including impact events from meteoroids or asteroids, tidal forces exerted by the Earth and the Sun, and extreme temperature variations on the lunar surface. Unlike earthquakes, moonquakes can last from a few seconds to as long as an hour and often occur in clusters. Scientists have proposed 2 potential explanations for these vibrations on the Moon. One possibility is that the Moon is contracting as it cools down, leading to stress on the interior and the formation of cracks and faults that trigger moonquakes. Another theory suggests that the Moon is heating up from the inside out, possibly due to the decay of radioactive elements in its core, leading to melting and the formation of magma pockets that trigger moonquakes. The detection of this moonquake by Chandrayaan-3 marks the first seismic event recorded on the Moon in over 50 years and could provide valuable insights into the Moon's origin and interior structure. The Pragyan rover's laser-induced breakdown spectrometer, LIBS, made a significant discovery on the Moon by detecting various elements, including aluminum, calcium, chromium, iron, manganese, oxygen, titanium, silicon, and sulfur. The presence of sulfur was particularly intriguing as it had not been detected by previous missions' orbiters passing over the Moon's south pole. Sulfur is associated with volcanic activity and can also be indicative of processes related to water ice. Despite the groundbreaking discoveries made by Chandrayaan-3, one important objective remained unfulfilled: the direct detection of water ice on the lunar surface. In 2008, India's Chandrayaan-1 mission detected signatures associated with water-bearing molecules in the Moon's polar regions. However, the Pragyan rover, like previous missions, did not find direct evidence of water ice during its exploration. There are two possible explanations for the absence of water ice detection. Firstly, it's possible that the Pragyan rover landed in an area devoid of water ice. Ice deposits on the moon are patchily distributed, with concentrations primarily found in lunar craters. Secondly, the sharp temperature decrease observed just below the lunar surface suggests that the moon soil may act as a thermal insulator, making it more likely for water ice to be present beneath the surface rather than on the surface itself. Despite the mission's inability to directly detect water ice, Chandrayaan-3 achieved its primary objective of making a soft landing on the moon and gathered valuable data during its descent. The Indian Space Agency's future plans include collaboration with Japan on Chandrayaan-4, which aims to extensively explore the lunar South Pole, focusing on making direct observations of water ice on the moon's surface. What do you think about this? Leave it here in the comments and take the opportunity to like the video and subscribe to the channel for more videos like this.